In this problem, they're giving you the name for a molecule and they want you to draw the structure. And the first thing is to start with the backbone. And the unique thing about these problems is that they are including a cis or trans prefix. So here we can see that this is trans. Okay, well the backbone is what comes after the last branch. And remember that a branch either ends in a YL if it's a carbon branch, or it ends in an O if it's fluorine, chlorine, bromine, or iodine. Here you can see that this O of the 2-chloro is the last branch that we have here. And so the backbone is ethene. The prefix for ethene is F, and that means that we're dealing with 2 carbons. The infix is En, and so that tells us that we have a double bond between them, and the rest are single bonds. And the suffix E is telling us that it's a hydrocarbon, so aside from the branches, everything is going to be a hydrogen. Okay, now I'm drawing this molecule, so I could number it however I want. I'm going to number it left to right. And on carbon number 1, the name says that I have a bromine. So I can put that either going up or going down. I'm going to put it going up. On carbon number 2, it says that I have a chlorine. But here, I have to put the chlorine going down. And the reason for that is because this is trans. These 2 branches have to be on opposite sides of the double bond. If you sort of draw a dotted line down the long end of the double bond, like this pink line here, you can see that the bromine is going up and the chlorine is going down. Because they're on opposite sides, it's trans. So I'd have to put them on opposite sides. I could have put the bromine going down and the chlorine going up. That would have been the same molecule. But because I put the bromine going up, the chlorine has to be going down. So once we have those branches in, we can just fill in the rest with hydrogens, and that would be our molecule. Now that's the Lewis structure. You could also draw the skeletal structure like this, with the bromine going up, and the chlorine going down, and the hydrogens are implied. So these are both valid structures for trans, 1-bromo, 2-chloroethene. How about cis-2-hexene? Now, I recommend when you have these cis or trans molecules, start with a double bond. Now, I know that I have 6 carbons here. The prefix is hex, and so we're going to eventually use 6 carbons. But the infix is En, and that means that I have at least 1 double bond. Let's start with that double bond. So I'll have 2 carbons on either side of that double bond. Now, the number in front is 2, and that means that the double bond has to start at carbon 2. If it starts at carbon 2, it goes to carbon 3. And so we have a foothold in the molecule. I know that there's 6 carbons, so I'm going to keep putting, here that's carbon 4, here this is carbon 5, here this would be carbon 6. And then on the left side, we have carbon 2, but there must be a carbon 1. And so we have that there. So now we have 2-hexene, and we know that we're going to have a hydrocarbon in this molecule because it's E at the end. So when we do fill all the bonds in, it'll be with hydrogen. But in front of everything, we have a cis. And the cis means that the branches coming off of the double bond, so this and this, have to be going on the same side of the double bond. So, in this example, I'm going to separate these, and I'm going to have them both going down. So we'll have that there going down, and then this other branch coming off going down. And so both of these would be going down, and up you would just have hydrogens. So this is cis-2-hexene. Cis because if you were to draw a line down the long end of the double bond, the carbon branches coming off of the 2 carbons in the double bond are on the same side of that line. In this case, they're both going down. Because of the E at the end, we know that this is a hydrocarbon, and so we can fill in all these other bonds with hydrogen. Now we know carbon needs 4 bonds, so we could fill in these others. So each carbon has 4 bonds. I'm going to put hydrogens at the end. This is the Lewis structure. You could also draw the skeletal structure, where the hydrogens are implied. To do that, draw a dot for your first carbon. You go up, over, you have the double bond, you go back down. It has to be like that because it's cis. They both need to be, you can't just do a regular zigzag. They both of the carbon chains coming off of that double bond have to be on the same side of the double bond. After you make the double bond, though, now you can go back to doing zigzags. We have already used 1, 2, 3, 4, and so we have 2 more carbons, 5 and 6. And so this would be the skeletal structure for cis-2-hexene. Either of these are valid structures for cis-2-hexene. Let's try trans-3-heptene. And let's start. Notice that you have the En in the infix. That means you have at least 1 double bond. So start by drawing the double bond. We know that we'll have a carbon on each side of the double bond. And if you notice, there's a 3 in front of the backbone. That means that the double bond starts at carbon 3. It always goes to the next carbon, so the other one must be 4. Now, these double bonds, when carbon has a double bond, it's usually trigonal planar. And so it's good to sort of draw a triangle off there. And now, we just need to fill this in. So the prefix is hept, and that means that we have 7 carbons total. So on the left, I could put it the carbon either going up or down. I'm going to put it going up. If this is carbon 3, this has to be carbon 2. And then we also need a carbon 1. So that'll be 1. And on the right, we'll have the next carbons. Because this is trans, because this carbon branch is going up, the other carbon branch has to be going down. And so carbon 5 will be going down, then carbon 6, and last, carbon 7. So that is the skeleton for trans-3-heptene. Because the suffix is an E, we know that it's going to be a hydrocarbon, so we just have to fill the other bonds in with hydrogens, and we know that each carbon needs 4 bonds, so we'll just fill these in with hydrogens at the end. So this is the Lewis structure. You could also draw the skeletal structure. And to do that, I would start with the double bond again. So that's 3 and 4. You know that on the left it's going to be going up, on the right it's going to be going down. So that's 2 and 5. And now you can just do the zigzag. So 5, 6, 7. And on the left, 1. Both of these are valid structures for trans-3-heptene.